Good morning. We're going over 3.6 today, which is rational functions. You have a bit of a cheat sheet in the first slide. This is everything you're going to need to be able to do by the end of this lesson. You're going to be able to find the domain, which is by setting the denominator equal to 0. You're going to have the vertical asymptotes, which you would get by setting the denominator equal to 0 and solving. You're also going to be able to find the horizontal asymptotes. There are 3 cases. The first case being if the number degree on the numerator is greater than the denominator, then that means there's no vertical horizontal. If the number degree is equal to the denominator degree, then we do it based on the leading coefficients. And if the degree of the numerator is smaller than the degree on the denominator, then you would have an horizontal asymptote at y is equal to 0. You also have slant asymptotes, which we use long division to find, which is the numerator divided by the denominator. You also have the y-intercept, which is when you set the x is equal to 0. You also have the x-intercept, which is when you set the numerator equal to 0 and solve. And then you have wholes, which is when you factor the numerator and denominator. And the factors that cancel out, you set them out to 0, and then you solve. Now, as you do problems, it's going to make more sense. For now, this is just the summary of what we're doing for the rest of the slides. So we have the rational functions and asymptotes. So the line x is equal to 0 is called a vertical asymptote. That is, at this moment, this line right here of the graph the graph in figure 1, and the y is equal to 0 is known as the horizontal asymptote, which is this line right here. Now, an asymptote, in other words, it's a line that the graph is going to get really, really, really close to, but it's never going to touch. So, informally speaking, an asymptote of a function is a line in which the graph of the function gets closer and closer as one travels along that line. So again, as you move across the line of the, in this case, 1 over x, then you would get closer and closer and closer to the asymptotes, but you're never going to reach them. Now, the definition of a vertical and horizontal asymptotes, you have the line x is equal to a being any number that's considered a vertical asymptote of the function y is equal f of x. If y approaches infinity either on the positive end or on the negative end as x approaches a from the right or the left. So here you have the notations. Y is approaching infinity as x approaches positive a. Y is approaching infinity as x approaches negative a. So the y is equal to negative infinity as x approaches positive a. And y is equal to negative infinity as x approaches negative a. Now again, this is all for one question of the homework where you're going to either plug in positive infinity or negative infinity. I just want you guys to get the concept of how the graph moves and how you would write it. Now, as of right now, I am still making the quiz, and you don't actually have to graph questions. For the homework, you do have to select some graphs, but you were able to select them by finding first the asymptotes, the domain, the range, the holes. You're going to be able to figure all that out, so just picking a graph in the homework will be easy. But you're not actually graphing in neither the homework nor on the quiz. Again, this is the definitions, but for the horizontal asymptotes of the function, y is equal to x. If y approaches b as x approaches positive or negative infinity, b being a random number, which is the horizontal asymptote. So a rational function has vertical asymptotes where the function is undefined. That is where the denominator is equal to 0. Now we have this problem. They're asking us to find the vertical and horizontal asymptotes, but we're not going to find that. We're going to find everything that we have on the cheat sheet. We're going to find the domain. We're going to find the vertical asymptote. We're going to find the horizontal asymptote, the x-intercept, the y-intercept, and the holes. Now, the work's going to be in the next couple slides. I'm going to always put the solution in this slide, and you can check the work out on the other slide. I'm going to add slides as I need for work, but just know in the recording it's going to show up all of the answers first and then the work based on how the slides are recorded inside of this app. Now, the solution, like I said, is negative infinity, comma, negative 2, union negative 2, comma, a half, union a half, comma, infinity. Again, here's going to be all the answers, the works in the next couple of slides. So the answer for the vertical asymptote is x is equal to negative 2, and x is equal to a half. Y is equal to 3/2. So for the x-intercept is negative 1/3, comma 0, and 1, comma 0. So the y-intercept is 0, comma a half. So we have no holes in this problem. Again, the work is on the next slide. So now I open up a new slide. This is, we're going to find the domain here. So how do we find the domain? We're going to equal the denominator to 0. So 2x squared plus 3x minus 2 cannot equal 0. We're going to factor this. So I'm going to go ahead and do 2x, and we're looking for factors of negative 4. The factors of negative 4 and 1 and 4, 2 and 2, 1 positive and 1 negative, of course. So I can go ahead and do plus 4 minus 1 in order to get the positive 3 to add. And this simplifies to x plus 2, and then 2x minus 1 cannot equal to 0. You're going to set each parentheses equal or cannot equal to 0. And you're going to solve for them. X cannot equal negative 2, and x cannot equal a positive half. So you're going to write the domain in interval notation. That's going to look like negative infinity, comma, negative 2, union, negative 2, comma, a half, union, a half, comma, infinity. Now, the next thing they want us to find is the vertical asymptote. So the vertical asymptote, good news is you're going to use the exact same denominator. It's basically the same work, but instead of equal cannot equal 0, we equal it to 0. You're going to factor. Again, I'm just going to go ahead and jump to the fully simplified factor part of the previous problem, which is x plus 2, 2x minus 1. We're again going to equal each parentheses to 0. And you're going to get x is equal to negative 2, and x is equal to positive a half. So the exact same numbers. The entire difference between domain and vertical asymptote is the fact that for the domain, it cannot equal to 0, and for the vertical asymptote, it can. And obviously, the way you write it. The way you would write it for the vertical asymptote is like this. X is equal, and x is equal. Now I'm going to go to the previous slide to write in the answer. Now let's look for the horizontal asymptote. Now the horizontal asymptote is again based on the leading exponent of this problem. So I'm going to only write the leading terms with the leading coefficients. Do you remember the rule? For when it has the exact same degree on the exponent, we only care about the leading coefficient. The leading coefficient in this case is 3/2. So my horizontal asymptote is going to be y is equal to 3/2. That's all you have to do for this problem, for the vertical asymptote, horizontal asymptote. Now I'm going to look for the x-intercept. Now for the x-intercept, we're going to equal the numerator to 0. So it's going to be 3x squared minus 2x minus 1 is equal to 0. I'm going to factor this problem, so it's going to be 3x. We're looking for factors of negative 3 that add up to negative 2. It's going to be minus 3 plus 1. This is going to simplify to x minus 3, 3x plus 1. And I'm able to solve them by equaling each parentheses to 0. And then I'm going to get x is equal to 3 and x is equal to negative 1 over 3. Now, you wouldn't write the horizontal asymptote like that. You would write it in an order pair. So it's going to be 3 comma 0, negative 1/3 comma 0. That would be your solution for the x-intercept. So for the y-intercept, we're going to plug in 0 for all of the x's of the entire problem. So I'm going to go ahead and just plug in the numbers first. So 3 times 0 squared minus 2 times 0 minus 1 over 2 times 0 squared plus 3 times 0 minus 2. This is going to be 3 times 0 minus 0 minus 1 over 2 times 0 plus 0 minus 2. Obviously, all of the zeros we can't add to it, so it's just going to be we're left with a negative 1/2 over 2. That can be simplified to positive 1/2. So our y-intercept is at y is equal to 1/2, which you need to write in an order pair, so it's going to be 0 comma 1/2, the final solution. And then we're going to be looking for the wholes. Now for the wholes, remember, we're going to factor the numerator and the denominator, so I'm going to write the entire problem first. So it's going to be 3x squared minus 2x minus 1 over 2x squared plus 3x minus 2. Now, we have already factored the numerator and the denominator. We factor the numerator with the x-intercept. So I'm just going to go ahead and write the simplified work. X minus 3, 3x plus 1. And we factor the denominator in the vertical asymptote and in the domain. So you can just go ahead and write the simplified version already. And remember, for the wholes, is after you factor it out, you want to look for the factors that are the same that you can cross out. In this case, we cannot cross any of them out, so it means there are no wholes in this problem. So for this one, let's find the exact same things. Instead of domain and intercepts, let's find the domain, the vertical asymptote, the horizontal asymptote, the x-intercept, the y-intercept, and the wholes. Now, since I saw that the last slide I was able to fit everything in one page, I'll try to do the same thing. If I'm able to do that, I'll just keep everything in one page and not write the answers here. If I'm not able to do that, I will add a slide with every answer. Okay, so let's start. I'm going to look at domain. Now, for the domain, again, we're going to use the denominator. So I'm going to go ahead and say x squared plus x minus 2 cannot equal 0. I'm going to go ahead and factor it. And you get x plus 2, x minus 1, equal each parentheses to 0. So x cannot equal negative 2, and x cannot equal positive 1. Again, we're going to write it in interval notation. So I'm going to go ahead and write for the final answer negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And then this would be your final answer. Now for the next one, vertical asymptote. We are doing the exact same thing, but instead of cannot equal, we write equals. So it's going to factor x plus 2, x minus 1 equals 0. You equal each parentheses to 0, and you get that x equals negative 2, and that x equals positive 1, that being your final answer. Now we're going to look for the horizontal asymptotes. Again, for the horizontal asymptotes, we're going to look for the leading coefficients in the numerator and the denominator. In the numerator is 2x squared, and in the denominator is just x squared. So the rule applies. We're only looking at the leading coefficients since we have the exact same exponents. So our solution is going to be that the horizontal asymptote is going to be y is equal to 2. Now we're going to look for the x-intercept. Now for the x-intercept, we're looking at factoring the numerator. So we're going to go ahead and write 2x squared plus 7x minus 4 is equal to 0. We go ahead and write 2x. We're looking for factors of negative 8 that add up to 7. So plus 8 minus 1 equal to 0. This is going to simplify to x plus 4. And this to 2x minus 1 stays the same. I can go ahead and equal each parentheses to 0. And we get that x is equal to negative 4. And that x is equal to positive 1/2. Again, for the x and y-intercept, you want to write it in an interval notation. So it's going to be 1/2 comma 0 and negative 4 comma 0 for the final answer. Now I'm going to start writing the y-intercept. We're going to equal everything to 0, all the x's. So it's going to be 2 times 0 squared plus 7 times 0 minus 4 over 0 squared plus 0 minus 2. Everything that has a 0 will become a 0. So we're left with y is equal to 0 minus 4 and 0 minus 2. That simplifies to negative 4 over negative 2, which simplifies to positive 2. So your y-intercept in interval notation is 0, 2. And lastly, we're looking for the wholes. I'm going to write the equation first. 2x squared plus 7x minus 4 over x squared plus x minus 2. We're going to factor the numerator and the denominator. In this case, the numerator, we simplified it already, factor it out in the x-intercept. So I'm just going to go ahead and write down the simplified version. And we factored out the denominator in the domain and the vertical asymptote. So I'm just going to go ahead and write down the simplified version. Now, none of these cancel out, so we would have no wholes. Now, I want you guys to note that I make sure that I always simplify these problems like this, because I know when I'm trying to find the wholes, the simplified version is probably the easiest, because it's the easiest way for you to be able to tell whether something can be simplified or not, because you can have multiple things, multiples of each other, and if it's not simplified, you might not notice, and you might miss the wholes question. So please make sure you simplify as much as you can before you can compare the numerator with the denominator in order to find the wholes. Some of them will be easy, some of them will be harder, but please simplify all the way so you can tell and not make a mistake. So for this one, example A, we're going to get common factors in numerators and denominators. So in other words, wholes. So they want us to graph the following functions. You guys are not graphing for this section. In the homework, I think I mentioned it already, you're going to be picking graphs, but you're not actually graphing. So let's just find the wholes. So for A, we have this problem as x equals x minus 3, and then x squared minus 3x. You're going to factor out what you can. So x minus 3, I can't do anything with it. But for the bottom, I can take out our greatest common factor. So I'm left with x minus 3, and then an x on the outside. Now these two are the terms that I can cancel out. So I'm going to use that term and equal it to 0. I'll add the 3, and I get x is equal to 3. Awesome. So we have a whole at x is equal to 3. In other words, you would write it whole at x is equal to 3. That would be the way you would write this solution. Now, we're going to do the same thing for b. T of x is equal, we're going to write the equation x cubed minus 2x squared over x minus 2. I can take out a greatest common factor in the top one, so it's going to be an x squared. So x minus 2, x minus 2 in the bottom. Those two happen to cancel out, so I can say x minus 2 is equal to 0. I'll add the 2 on both sides and get x is equal to 2. So you would write your solution as whole at x is equal to 2. Alright, so for this one, we're going to find the same things we've been finding for all of them. The domain, the vertical asymptote, the horizontal asymptote. We're going to look for the slant asymptote, which is something we haven't done yet. The x-intercept, the y-intercept, and the holes. Now, just like the other problems, I'm going to open a new slide to start working on these. Now, for the domain, we're going to grab the denominator of this problem, which is x minus 3. So we're going to say x minus 3 cannot equal 0. So our domain is everything except 3. So we would write it as negative infinity to 3 union 3 to infinity. This will be the solution for the domain. Now, let's look for the vertical asymptote. For the vertical asymptote, we again are going to grab the denominator and just go x minus 3, and this time can equal 0. So we'll add the 3, and we get that x is equal to 3. Now, that is your solution for the vertical asymptote. Now, let's look for the horizontal asymptote. We have the biggest exponent on the numerator is x squared. The biggest exponent on the denominator is x. The rule is if you have a bigger numerator than a denominator, that means you have no horizontal asymptote. So here your answer would be none. Now I'm going to look for the slant asymptote. The way you do that is you're going to do long division from the numerator divided by the denominator. So let me put it down here. So the slant asymptote, I'm going to go ahead and say, well, x squared minus 4x minus 5 is divided by x minus 3. Let me rewrite that so it fits. So I'm going to go ahead and get started with the long division. I need an x in order to match the x squared. So this is going to become x squared minus 3x. Remember, when you're subtracting the entire parentheses. So this becomes minus and this becomes positive. So these are going to cancel. And I'm left here with a negative x. Bring down the negative 5 minus 5. Now to make the x into a negative x, all I have to do is multiply by negative 1. So this is negative x, and this is positive 3. Again, when we subtract the entire parentheses, so it's going to be a plus x, and then a minus 3, leaving this to cancel, and we're left with negative 8. Now, we don't really care much about the remainder for this problem, so our slant asymptote is going to be y is equal to x minus 1 as your final answer. Now we're going to look for the x-intercept. That is when we're going to grab the numerator of this problem, which is x squared minus 4x minus 5 is equal to 0. And we're going to factor it. So we're looking up for factors of negative 5 that add up to negative 4. So it's going to be x minus 5. X plus 1 is equal to 0. We're going to go ahead and equal each parentheses to 0. And we're going to get that x is equal to positive 5 and x is equal to negative 1. But since it is an x-intercept, we're going to have to write it in an order pair. So we're going to get 5, 0 and negative 1, comma 0. Now we're going to look for the y-intercept. Now for the y-intercept, I am going to plug in 0 to all of the terms that have an x. So it's going to be y is equal to 0 minus 5. Wait, let me not skip a step. Y is going to equal 0 squared minus 4 times 0 minus 5 over 0 minus 3. All of the ones that have a 0 will cancel these terms, so we're left with negative 5 over negative 3, which simplifies to 5 over 3. Therefore, y-intercept is 0, comma 5 over 3 for the solution. Now we're going to be looking for the wholes, which is the last thing we have. Again, we're going to factor the numerator and the denominator. I'm going to write out the equation first. Now, we already factored the denominator. There's nothing to factor with it. It's just x minus 3. And we already factored the numerator for the x-intercept. So I'm going to go ahead and just write x minus 5, x plus 1, and then down here, x minus 3. Now, there's absolutely nothing we can cancel, so therefore, we would have no wholes in this problem. Okay, so we have 3 problems, and they're looking for the zeros, the vertical asymptote, the horizontal asymptotes, the wholes, y-intercepts, domain, and slant asymptotes. So let's figure this out. The zeros, it's part of the domain, is where the graph is going to equal 0. So we'll get the zeros when we get the x-intercepts. Those are the same things. So let's start with the zeros so we can go in order. So for the zeros, or x-intercept, we're going to grab the numerator, x squared plus 4x minus 5 equal to 0. We're looking for the factors of negative 5 that add up to positive 4. So we'll get x plus 5, x minus 1. Now this is going to equal x is equal to negative 5, and x is going to equal to 1. So since those are the zeros, and you can write them, if it's at 0, you can say x is equal to negative 5 and x is equal to 1. But you can also write them as an x-intercept, which would be as negative 5 comma 0 and 1 comma 0. If it says x-intercept, please write them in an order pair. Now we're going to look for the vertical asymptote. That is the denominator, so x plus 1 can equal to 0. So our x can equal to negative 1. So vertical asymptote, I'm just going to go ahead and write x is equal to negative 1. The horizontal asymptote is based on the exponents. We have the exponent for the top x squared. The exponent for the bottom, the leading one, is 1. So because the 2 is greater than the 1, so the numerator is bigger than the denominator, we don't have any horizontal asymptotes. So you can write none. Now let's look for the wholes. I'm just going in order. For the wholes, we're going to factor the numerator and the denominator. We already factored the numerator when we did the x-intercept, so I'm going to go ahead and write x plus 5, x minus 1, and then on the bottom, we can't really do anything, it's x plus 1. We can't cancel any of these, so we have no wholes. For the y-intercept, we equal every x to 0. So it's going to be 0 squared plus 4 times 0 minus 5, 0 plus 1. That's going to give us negative 5 over 1. So we get negative 5. So the y-intercept is going to be 0, comma, negative 5. For the domain, we deal with the denominator. So for the domain, it's going to be x plus 1 cannot equal 0. So x cannot equal negative 1. And in slope-intercept form, that would be negative infinity to negative 1, union negative 1 to infinity. And lastly, we have the slant asymptote, which I'm going to do up here. It's going to be x squared plus 4x minus 5 divided by x plus 1. So we're going to look for first an x. So this is x squared plus x. When we subtract, this becomes negative, this becomes negative. So it's going to be, this cancels out. 3x minus 5. Now I'm going to go ahead and write plus 3. It's going to be 3x plus 3. This will turn negative. This will turn negative when you subtract. These cancel and you're left with negative 8. But the slant asymptote is the x plus 3. So we would write it as y is equal to x plus 3. Now let's look at the second problem. I'll do it in a different color so the problems don't mix with each other. Again, we're looking for the zeros, or in other words, the x-intercepts. We're going to grab the numerator and say x squared plus 5x plus 6 is equal to 0. We're looking for factors of 6 that add up to 5, so 2 and 3. It's going to be x plus 2, x plus 3 is equal to 0. So our x-intercepts are x is equal to negative 2 and x is equal to negative 3. Again, we'll write them in order pair form, so it's going to be negative 2 comma 0, then comma, negative 3 comma 0. Now let's look at the vertical asymptote. The vertical asymptote is based on the denominator, so I'm going to go ahead and say x squared minus 9 can equal 0. So x squared equals 9. We take the square root, we get x is equal to plus or minus 3. So we have two vertical asymptotes in this problem. We have x is equal to plus or minus 3. You can write it as x plus 3 comma x minus 3, but you can also write it as just one time and write plus or minus. That's completely fine. Now we're going to look at the horizontal asymptotes. It's based on the highest degree from the top and the bottom. The top is x squared, the bottom is x squared. Now the rule is, since these two are exactly the same, we're going to look at the coefficients. The coefficients for both of these are 1. So our horizontal asymptote is 1, which we would write as y is equal to 1. Now we're going to look for the wholes, which is just going to factor the numerator and the denominator. Now the numerator we already factor, and it's x plus 2, x plus 3. In the denominator, it's a perfect square, so you can factor it as x plus 3, x minus 3. Now, in this case, we do have a factor that we can cancel out, which is the x plus 3. So I can go ahead and say, well, x plus 3 equals 0. So we have a whole at x is equal to negative 3. So you can say whole at x is equal to negative 3. Now for the y-intercept, we're going to plug in 0 for every single term that has an x. So it's going to be 0 squared plus 5 times 0 plus 6 over 0 squared minus 9. Everything that has 0 cancels, so we're left with 6 over negative 9. That can be simplified to 2 over negative 3. So the y-intercept we're going to write as 0 comma 2 over negative 3. Now for the domain, it's the denominator, so it's x squared minus 9 cannot equal 0. We already solved it out with the vertical asymptote, so I'm going to go ahead and write x cannot equal plus or minus 3. So you would write it as negative infinity to negative 3, union negative 3 to positive 3, union 3 to infinity. And then lastly, we're going to do the slant asymptote, which is going to be the top divided by the bottom. So I'm going to take the space down here. So it's going to be x squared plus 5x plus 6 divided by x squared minus 9. Now, since the x's are the same, I can just go ahead and write 1. So it's going to be x squared minus 9. But that's not going to work because we can't do anything with the 0. So in this case, since we have the exact same one, we're not going to have a slant asymptote, so we can't really divide it or simplify this in any way unless we factor out and then we have x plus 2 divided by x minus 3, which again is something you can't really do with long division. So for the slant asymptote, I would put none. But for the quiz or test, you will have stuff that works out. So you're not going to have this as an option for the quiz or the test. If you get asked a slant asymptote, you will have one. Now let's look for the zeros of the third one. So again, we're going to start with just like the x-intercepts. That's going to be the numerator, which is x squared minus 4 equal to 0. This is a perfect square. But you can go ahead and move the 4 over and get x squared is equal to 4. So x is equal to plus or minus 2. Which again, you could have factored it as a perfect square and you would have gotten x plus 2, x minus 2 equal to 0. And then after you equal each parentheses to 0, you would have gotten that x was equal to 2 and x was equal to negative 2. So you can go ahead and just say 2, 0 and negative 2, 0 is where the zeros are. We're going to look for the vertical asymptote. That's the denominator. So it's going to be 3x squared minus 15x is equal to 0. I'm going to go ahead and take out the greatest common factor of 3x. So I'm left with x minus 5 is equal to 0. Now 3x equal to 0. And then x minus 5 is equal to 0. So x equals to 0 and x is equal to 5. Those are the vertical asymptotes. I'm going to go ahead and write them in. X is equal to 0. X is equal to 5. Now for the horizontal asymptote, it's based on the exponent of the numerator and denominator. The biggest exponent is x squared, and the biggest exponent on the denominator is going to be 3x squared. Now because they are the exact same x squares, we're going to go ahead and do it based on the coefficients, which happen to be 1/3. So we can say that our horizontal asymptote is y equals to 1 over 3. Now we're going to be looking for the wholes. Now the wholes again is just factoring the top and the bottom. We already factored the top as x plus 2, x minus 2, and then the bottom we factored already as 3x, x minus 5. Nothing cancels or nothing's possible to cancel, so we would have no wholes, so we write none. Let's look for the y-intercept. The y-intercept is plugging in 0 for any x. Now all the zeros cancel and you're left with negative 4 over 0. Now having a 0 in the denominator is not possible, so that means you have no y-intercepts. And then we have the domain. Let's figure it out. So the domain is based on the denominator. So it's going to be 3x squared minus 15x cannot equal 0. We factor that to 3x, x minus 5 cannot equal 0. So our x cannot equal 0 or positive 5. So we go ahead and write the domain as negative infinity to 0. Union 0 to 5, union 5 to infinity. And lastly, we have to find the slant asymptote. Again, so this one's going to be 3x squared minus 15x divided by x squared minus 4. Now we would start with the 3. We can divide even if it's just by one number because we have coefficients, so this would be 3x squared and then minus 12 because we can't really combine anything that with the x that we don't have. You go ahead and make everything, when you subtract this negative and this positive, this one cancels and I'm left with 15x plus 12, but that's okay, we don't care about the remainder. Our solution in this case is 3. So we have a slant asymptote at y is equal to 3. Now, that would look as a horizontal asymptote as we have no x. But again, for the quiz or test, you would have an asymptote like the first problem, which would be x plus minus a number. Not like this one, the last two, which were a little funky.